In this lesson, you will learn about dilations of triangles. A dilation is a type of transformation that changes the size of the figure but will not change the shape. A dilation of a figure will result in a similar figure. A dilation has a center of dilation and a scale factor, which together determine the position and size of the image of a figure after the dilation. We will be doing dilations where our center of dilation is the origin. If a scale factor is between 0 and 1, so a fraction or a decimal that's between 0 and 1, it will result in a similar figure that is a reduction or smaller than the original figure. A scale factor that's greater than 1 will result in a similar figure that is an enlargement or larger than the original figure. The original image, if you'll remember when you're doing transformation, the original image will be referred to as the pre-image, and the resulting figure will be referred to as the image. Also remember your notation. So if we're talking about a triangle ABC, that is the pre-image. When we do our transformation, we'll have triangle A prime, B prime, C prime. So for each graph, we're going to find the coordinates of the image after the dilation using the given scale factor. We're going to graph and label the image and determine if the dilation was an enlargement or a reduction. So let's look at example 1. Here we're going to do a dilation of our triangle SFH, we see here on our graph, using a scale factor of 1/2. So before we can do that, we'll first need to list our coordinates of the image that is given. So first we have S, and that's at -2, +4. Remember, it's an X and then a Y ordered pair. If you want to label X and Y. F, that's at -6, +6. H is at -4, 2. So those are our ordered pairs of the pre-image. So now using our scale factor, we were told to use K equals 1/2. We will find the coordinates of the image. So our coordinate notation, we're going to take our XY ordered pair, and to dilate it, we're going to take 1/2 times our X and 1/2 times our Y to find our new ordered pair. So for each of those, S prime, -2 times 1/2 is -1. 4 times 1/2 is 2. So for F prime, -6 times 1/2 is -3. And 6 times 1/2 is +3. And then H prime, -4 times 1/2 is -2, and then 2 times 1/2 is 1. So you just multiply the X and the Y by your scale factor in order to find your new ordered pairs. Let's graph these ordered pairs for our image. So -1, 2 is our S prime. Be sure to label your points as you graph them. -3, 3 is our F prime. And then H prime is at -2, 1. We do see that it has given us 3 points that are similar to the 3 points we started with, but it's a reduction because our K value was less than 1. So it did shrink or make smaller our figure. So connect those points with the straight edge. And be sure to answer the last part. We have found the coordinates of the image after the dilation. That was these S prime, F prime, and H prime. We graphed and labeled our image, and now we're going to need to determine if the dilation was an enlargement or a reduction. And we've already seen that it is a reduction because our scale factor was less than 1. Let's look at example 2. Again, start by listing your ordered pairs for the pre-image. So we have A, B, and C. Oh, A, B, and M. A is at 1, -1. Again, it's an X, Y ordered pair. B is at 1, -3. And M is at -1, -1. For this scale factor, we're given a K equals 2. So we're going to take our XY ordered pair. In order to perform our dilation, we're going to take our X and multiply it by 2 and multiply our Y by 2. So let's do that with each of our points. So for A prime, multiplying both the X and the Y by 2, we get 2, -2. For B prime, multiplying both our X and Y by 2, we get 2, -6. And our M prime, we get -2, -2. So let's label or graph and label these points. So 2, -2 is our A prime. 2, -6 is our B prime. And -2, -2. So again, we see a similar figure. It's just grown in size because our K value was greater than 0. So it does make an enlargement. Connect those points so we can see that triangle has grown in size, but it did not change its shape, it just changed its size, and that's what a dilation will do. Just changes the size, not the shape. So it is a similar figure. And because it did grow in size, we will call this an enlargement. So for both of these graphs, our center of dilation was the origin. As the graph shrank, it shrank with the center of dilation at the origin, or as it grew with the center of dilation again at the origin. So let's look at that in our next part. A center of dilation is a fixed point in a plane about which all points of the figure are going to expand or contract. The center of dilation is the only non-changing point under a dilation. It may be located inside, outside, or on the figure. So a center of dilation can be any point in the plane of where our figures are. So this center of dilation is here. You can see the original image may be this triangle ABC, and it grew to be this triangle DEF. So you see along these lines is how it will dilate, either growing or even shrinking. So if your original figure was this DEF triangle, then it can also shrink within these lines by that center of dilation. So to find a center of dilation, you're going to draw straight lines using a straight edge like a ruler, connecting the points from the pre-image to its corresponding point on the image. So that's important, that if you have A, you're connecting it to A prime, or B, you're connecting it to B prime. We're going to extend the line past the points because remember, the center of dilation can be located inside, outside, or even on the figure. So you never know where it will fall. So always extend your line past the points until you see them starting to intersect. You're going to repeat that repeat that step for all the points on the figure. So if you're working with a triangle, you'll do that 3 times. If you're working with a pentagon, you'll do it 5 times. If you're working with octagon, you'll do it 8 times. So depending on how many points you have on your figure, that's how many times you'll have to draw a line. And then finally, the point where all those lines intersect is the center of dilation. So let's look at that now. So example 3, we're going to find the center of dilation. So if you'll notice, we have our figure. and we are labeled F and F prime. So line up your straight edge with F and F prime and draw a straight line connecting those points. Notice how I extended that line all the way through the figure because we never know where the center of dilation may be. So do each point of the figure, so S to S prime, again extending through the points, and then H and H prime. So if you'll notice where those three lines intersect, and we have three lines because we only have a triangle, you'll have more lines if you have more points on your figure. But we have three lines because of a triangle, and those three lines are going to intersect here at the origin. It is the same graph that you just graphed up in example 1, and that dilation was about the origin, and so that's why it crosses there at 0, 0. Let's look at example 4. Do the same thing here, connecting your points A to A prime. You will not want to connect the points any other way. Make sure you connect the corresponding letters. So B to B prime, extending all the way through. And again, we'll find that it is going to cross through the origin because, again, this is the dilation we just did in example 2. So again, here's our center of dilation at the origin. Example 5 and 6 are different, so let's look at those. For example 5, again, we're still going to connect A to A prime. But notice that goes nowhere near the origin, so that dilation did not go about the origin. It did start here at A, B, and C, so it increased to A prime, B prime, and C prime. So it was an enlargement, but it did not go anywhere close to the origin. So our center of dilation will not be the origin. Let's find where it will be. Line up B and B prime with your straight edge. We're starting to see it intersect here in the middle, so let's finalize with C and C prime. And it is there in the center of that first figure, ABC. A dilation can occur inside, or the center of dilation can occur inside the figure, outside the figure, or even on a figure. So our last example here, again, lining up the points, X to X prime. Z to Z prime. And once again, notice that we're not even anywhere close to the origin. So Y to Y prime. Oh, I'm a little off somewhere. Maybe my X was not very good. And it's not getting much better. But it's somewhere right in that area. We have our center of dilation.